Okay, so we are going to learn about orbital diagrams, and you're going to need your periodic table out, and you're going to need your notes about the electron that we discussed in class that look a little bit like this. This is where we'll pick up. I will need to go back and review just one other thing real quick on this PowerPoint. If you'll go up to this slide. So we discussed a couple of days ago that Werner Heisenberg said that there's no way for me to know the exact path of an electron. I can't predict exactly where it's going to be at any one point in time. So instead, what we do know is we know a relative region of space that it's located in around the nucleus. So there are different what we call orbitals, which are three-dimensional regions that the electrons can float around in and move around in. And there are 4 different types of orbitals, and they all have different shapes. The S orbital is a sphere. It's the smallest of all the different types of regions of space that they can occupy. So if you're thinking about this like it's a hotel room that the electrons live in, the S would be the smallest room that you can get. It only has 1 bed in it, and 2 electrons can sleep in it, since you can have them sleeping 2 to 1 bed. They also are going to be sleeping head to toe, and all of that has to do with a few different scientists that are later on in the PowerPoint presentation. The P room, or the P orbital, that electrons can fly around in or sleep in, if you're talking about them like their hotel bedrooms. There are 6 beds in that room. I'm sorry, take that back. There are 3 beds in that room that can hold 6 electrons. So if you were to knock on a P room and you were to open up the door, you would see 3 beds, and you could put 6 people in it. The D orbital has a different shape. The P orbital actually looks a little bit like almost like a bow tie that you spun around, so that makes a 3-dimensional region, a lobe almost. A D sort of looks like 2 P's that are joined at the middle, and an F is a little bit unpredictable. But the D will have 10 beds in it, or 10 D orbitals. So 10 different beds the electrons could sleep in. Take that all back again. Sorry, it holds 10. It actually only has 5 beds. So and 7 has 7 beds. The F has 7 beds and can hold 14. So let's just, error message keeps coming up and I can't get rid of it. Don't know how to get that. All right, so let's look at that out of the way right here. All right, so this S actually has 1 bed in the room. 2 people can sleep to the bed, so it actually will hold 2 electrons. The P has 3 beds. Since 2 can sleep to a bed, it will hold 6. There are 5 beds in a D room, or in a D orbital. And there are 7 beds in the F. So as long as you know that you can fit 2 to a bed, then you should be in pretty good shape. Let's go down a couple of slides really quickly on the PowerPoint. And you have 3 different principles that you need to know about, and you will be tested on when we take a test over this unit. One is the off-ball principle. The off-ball principle says that you have to fill up these beds, or put electrons into a room, based on lowest energy first. So you're going to move, there's a certain pattern we're going to walk through in how you can put your electrons into a bed. The Pauli exclusion principle says that if I have 2 electrons that are paired together, so in the same bed at the same time, they have to have opposite spins. So for us, if we're talking about a hotel room, we're going to think of it as they're sleeping head to toe. One will have their head at the top and the other will have their head at the toe. And then Hund's rule says that if I have, let's say I've got 3 people that I need to put into a P room, and there are 3 beds, I'm going to put 1 in each bed first. And that makes sense, because why would you put 2 in 1 bed and then only 1 in the second and leave 1 empty? So Hun says you need to put 1 in each bed before you can pair any of them up. You need to know who does what and how they're represented. And we're going to walk through our orbital diagrams so that you can use these rules and apply them, so that when you are faced with them on your test, you'll be able to explain them. I need to go back up another slide or 2. I think it's actually, there's that error message again. Right here, it's got these lines going through. So we call quantum numbers, I discussed this in the notes when we were together in class, that quantum numbers are basically energy levels, that all the electrons that live in the first energy level, which is a quantum number 1, have 1 quantum of energy. Second energy level is 2 quantums of energy, and so on and so forth as you move away. So each of those energy levels, because they increase in size and they increase in energy as you move out, have a certain number of rooms. So if we're going back to the hotel room and we're using the off-ball principle that says I have to fill up my rooms in order of increasing energy, I'm going to do it in this order. You can think of these lines sort of as arrows. So that I have to follow the arrows to fill up my rooms in the hotel. This number that's out in front tells you which floor you're on in the hotel, and the letter describes what size of the room you're going to, or for us it would be shape of an orbital. So if I wanted to put my electrons into some sort of, try to give them an address where they're going to sleep for the night, I have to go in this order, and it's going to look a little bit like this. You're going to want to write these down, make sure you're using your periodic table as you go through. So we're going to start with a small one. Maybe let's start with iron. It's not too big. In order to give all of the electrons in iron a place to sleep, first I need to figure out how many electrons need somewhere to sleep. And I go to the periodic table and I should find that iron has 26 electrons when it's neutral. And I'm going to go back and I'm going to go to the hotel and try to put them all into rooms in the order that off-ball tells me I need to put them in. And that order is going to be using this chart from your notes. I go to the first floor. The only room on the first floor is an S room. The S is the smallest. It only has one bed in it. So if I'm going to put that into a diagram, I have one bed. And that bed is the first floor in the S room. I can put 2 electrons in there and they have to sleep head to toe. That's what Polly told me. They need to have opposite spins. If I were to point them in the same direction, then I would be going against the Pauli exclusion principle. So I'm going to take 2 of them away because 2 of them now have a place to sleep, and I'm left with 24. I go back to my diagram, and after the 1S, I have to go to the 2S. So I'm on the second floor S room, and just like every S room, it only has one bed. Second floor S room has one bed. 2 electrons can sleep in there. They have to sleep head to toe. It's all full. I used 2 of them. Now I'm down to 22. Go back to your chart that shows you the order they have to go in. The next one is going to be the second floor P room. Now P room is a little bit bigger. Every P room, regardless of what floor it's on or what energy level it's in, has 3 beds in it. So for us, that would be 3 orbitals. I can diagram that by basically drawing a diagram for 3 beds. And this is the second floor P room. When I knock on the door, I open it up, and there are 3 beds. So what Hun said is, in order to fill up these beds, first I need to put 1 in every bed. So I'm going to do that, and I have to be pointing in the same direction. You could point them all down, that's fine, but they all have to start pointing in the same direction. Once I have 1 in each of them, I can go back and pair them up. So my P room is full. I just used 6 of my electrons. I'm now down to 16. Go back to my diagram. After the 2P, I'm going to follow my arrows, and it points me to the third floor S room. And just like every S, there's only 1 bed in it. So third floor S room. It can hold 2 electrons. They will sleep head to toe. I'm going to go back to my chart, follow the arrows. The next one I go to is the third floor P room. And just like the second floor P room, there are 3 beds in it, or 3 orbitals, P orbitals, three-dimensional regions. They are. Third floor P room, I put 1 in each first, pointing in the same direction. And if I have enough, I can go back and pair them up. I just used 6. I still have 8 left to place. So now I'm going to go back to my diagram. Notice that I was on the 3rd floor and I put all of my electrons into a P room, but I don't finish on the 3rd floor. That's not what they're telling me to do right now. If I follow my arrows and I was at 3P, the next place I go is 4S. So I'm going to jump up to the 4th floor now and go to an S room that only has 1 bed in it and holds 2 electrons that I can put in opposite spins. I have 6 left that need a place to sleep. Now I'm going to go back and look at my chart again. I just came from 4S. Now it's going to go back down to the 3rd energy level, the D room. D rooms are bigger. When I knock on the door of a D room, there are 5 beds in it. So I'm going to go back and draw a diagram of 5 beds. 1, 2, 3, 4, and 5. Oh, those are all on the 3rd floor in a D room. After I put those 2 in my 4th floor S room, I'm going to go backwards, and now I can put some more on the 3rd floor. So first I have to put 1 in each bed, pointing in the same direction. And since I needed 6, still needed a place to sleep, I have 1 extra one. So that one is going to have to pair up with somebody and point in the opposite direction. And I have just given all of my electrons a place to sleep. If you notice, my 4th floor was my outside energy level. It only had 2 electrons in it. Those are my valence electrons. It doesn't matter that the 3D is the one that I put electrons into last. In order to figure out valence electrons, I have to look at where the outside energy level is. And I was on the 4th floor once, so that's where my outside electrons are going to be. This is why I never get more than 8. After you get to the 3rd floor, you'll put 8 into the 3rd floor before you have to go to a different energy level, and then go back and fill up some more in the 3rd later. Let's do one that's a little bit bigger. Let's do I'm going to do a pretty big one, and I'm going to go to osmium. This one's big. It's really big, actually. And look on your periodic table. Osmium's number 76. I have 76 electrons that need a place to sleep, and I'm going to follow the same pattern every time. I'm going to go back to the chart in my PowerPoint presentation, and I'm just going to follow the arrows. So I'm going to go 1st floor S room, 2 electrons sleeping in the same bed, head to toe, 74. I'm going to go back again. Now I'm at 2S. 2nd floor S room, 2 electrons can sleep there. And left. Go back again. From 2S, I go to the 2P. Follow the arrows. On the P bedroom, I have 3 beds. Put 1 in each first. And then I go back and pair them. So I used 6 of them. I'm now down to 66. I go back to my PowerPoint. After my 2P, I go to 3S. 3rd floor bed. Fits 2 electrons. And I'm down to 64. After my 3S, I go to my 3P. 3 beds in it, regardless of what floor they're on. Remember that I'm talking about beds in hotel rooms, but these are really orbitals or 3-dimensional regions of space that the electrons can fly around in based on their energy levels. They do increase in size and they increase in energy as I go through this chart. As it turns out, things like 3D and 4S are actually pretty close to each other, even though the 4th energy level is out 1, but they're pretty close to each other in energy. So after I go to my 3P, I'm going to go 4S. 4th floor S room holds 2 electrons. 2. After 4S, I can go to 3D. D room has 5 beds. Each first. Used up 10 of them, so now I am down to 52. Still have a lot to go. They're going to start filling up a little bit faster now, though. All right, I just used 3D. Now I can go to the 4th floor P room. And in a 4th floor P room, I have 3 beds, just like in every P room. I can go ahead and put 1 in each first, go back and pair them up. Remember, Hund's rule is the one that says you have to put 1 in each bed first, and the Pauli exclusion principle says you have to go back and pair them up in opposite spins, opposite directions. Just use 6 more, I'm down to 46. All right, I just used 4P. I'm at 5S now if I follow my arrows. Put 2 in there, so I had 46. I'm going to take 2 away, down to 44. After 5s, I'm going to 4d, and the 4d energy level can hold 5 beds, right? First, I'm down to 34, making some progress. After my 4d, I go to 5p. Down to 28. Now I'm at 6s, jump up to the 6th energy level. I just used 2, I have 26 still. Now things are really going to start moving because now I have an F room, and an F room actually has 7 beds in it. This is my 5F, actually, I might take that back, I'm sorry. It's my 4F that I went to, so I had to go all the way back to the 4th energy level for that. I'm going to put 1 in each first. And go back and pair them up. If I can, if I have enough electrons. So I had 14 that I just used, and now down to 12. After 4F, I follow my arrows, I go to 5D. There are 5 beds in every D room. One, 2, 3, 4, 5. I do need 12 more, so I'm going to go ahead and fill my D up. And I am left with 2. If I go back to my chart after my 5D, I go to the 6P. I only have 2 electrons left, so what I'm going to do is put them in that P room in separate beds pointing in the same direction. That was long. You won't have that many of these that are going to be that long, but just so that you can see the D's and the F's and all of that. So the next question is, how many valence electrons does this have? Remember, valence electrons, it doesn't matter which ones you actually put into rooms last. What matters is the highest quantum number, the highest energy level. So I go back and look, and it looks like the 6th energy level was my highest. I have them coming from here and from here in the 6th energy level. They're in different rooms, but they're on the same floor. So how many valence electrons would this have? It would have 4 because I have to add those up. All right, so go ahead and practice this on your practice sheet.